All right, let's take a look at what it means to solve an equation by using log base 10, and why base 10 is important when we talk about logs. Solve this equation. So in other words, find a value for x that makes this true, which is not easy just to sort of do by trial and error. It's going to be a decimal of some sort. So how do we use logs to solve it? First of all, I'm going to take this whole equation and I'm going to rewrite it in its log form. So remember we said the base of our index becomes the base of our log, so log base 3. The next value is the value that it equals. So the log base 3 of 5 equals, then my index becomes this part of my log equation. So that was from an earlier video. You can go back and have a look if you need to. These two things are the same thing. This and this are the same thing, just written in different forms. All right, now that's handy if you've got a calculator that has this button, a log base. It's got the base and it's got the value that you can put in. Unfortunately, our Casio FX82s don't do that, because if you did, you could simply plug in that value, and you'd get your answer. But we do have a way of working around that, because our calculators do have this button. It just says log, and it actually means log to the base 10. And we're going to use that to solve our equation. So let's have a look at how we do it. I'm going to take the log 10 of both sides. So remember, you can do whatever you want to an equation, so long as you do the same thing to both sides. So one thing we can do is take log base 10. So all I've done is I've added log to the base 10 to both sides of my equation, right? I've added it there and there. And here's my new equation. Hopefully you can remember from a previous video the log laws that says, well, if I've got this index, I can actually bring it around here in front. So that index inside of a log, I can bring it out to the front. So now I've got x log 10 base 10 of 3 equals log base 10 of 5. Okay, how do I get rid of this bit? Because I'm trying to get x on its own. Well, I divide both sides by log base 10 of 3. Okay, whatever I do to one side, I have to do to the other. And just like we would do in algebra, the reason I've done that is now I can cancel out the log base 10 of 3. Which is great, because my goal, remember, was to get x on its own. So here's what we've got so far. I've tidied everything up. And the beauty of this now is, because we've got this log base 10 button, I can put this into my calculator. Okay, I can just simply hit these buttons. Log 5, but remember to close the bracket so it doesn't get too confused, divided by log button of 3, close the bracket again, hit equals, and I'm going to get a value of 1.465. We have solved it. X, this value here, 3 to the power of 1.465 equals 5. Great job. Let's look at one more example. This one we have to do a little bit of a tidy up first, because I've got some things I can tidy up here. I've got this times 1,000. So I'm going to get rid of it by dividing both sides by 1,000, which means my right-hand side now becomes 0.1. This is great, because this is in a format very similar to what I had over here. I can take log 10 of both sides and follow the same process. I'm going to bring my index over in front of that log. And to get the x on its own now, I'm going to divide both sides by log base 10 of 0.93. They will cancel out. And the remaining, the sum that I have, the equation is x equals this, which I can put in my calculator. And when I do that, I get a value of 31.7289. You have solved it using log base 10. Great job. Well done.